Fixed charge cations with elemental anions. Okay, what are elemental anions? Well, elemental anions are pulled off the table anions. In other words, they are negatively charged species that tend to come from this portion of the periodic table. Typically we leave the noble gases off of there, but pulled off the table anions come from this upper right region of the table. The fluoride ion, the oxide ion, the nitride ion, the sulfide ion, the chloride ion, bromide, iodide, selenide, and so on. Those are elemental anions. The fixed charge cations, when we say fixed charge, that refers to cations that whenever they form a cation, they always have a particular charge, never anything else. Let's say you're an atom, and sometimes you lose 2 electrons, and other times you lose 4. You're not a fixed charge cation, because sometimes you lose 2, sometimes you lose 4. Whereas me, for example, let's say I'm a fixed charge cation. Anytime I lose electrons, I always lose 1. Every single time, never anything else. Another fixed charge cation, he always loses 2 electrons. Every time, never anything else. So these fuchsia colored boxes are the fixed charge cations. That would be group 1, which is over here on the left. Those guys always lose 1 electron, never anything else, and so their charge is always 1 plus. These are the alkaline earth metals. They always lose 2 electrons, never anything else. Their charge is fixed at 2 plus. The group 13 elements are over here, this vertical column. They always lose 3 electrons, so their charge is always 3 plus. And then there are a few others that wouldn't hurt you to memorize. Now, if you had to pick and choose between these other fuchsia colored boxes to memorize, if you absolutely can't memorize all of them, the ones you'll want to memorize are these 3 right here. Silver is right there. Silver always loses 1 electron, and so you can see right there in the middle screen, its charge is always 1 plus. Anytime silver loses an electron, it always loses just 1. Zinc, on the other hand, is right here. Whenever it loses electrons, 2. Every time. Cadmium, right below that, loses 2 every single time. Those 3 exceptions, at a minimum, you have to memorize. Silver is always 1 plus. Zinc and cadmium always 2 plus. If you want to stretch your mind a little bit, there's a stair step on the other side, and those elements almost always lose a specific number of electrons. Scandium and yttrium always lose 3. Zirconium and hafnium always lose 4, and then the bottom of the stair right here, tantalum, almost always loses 5. So the stair step on the left, I'm not as concerned about you knowing, but the stair step on the right, you absolutely have to know, as well as the full columns, what the charges are on those cations. Alright, with fixed charge cations, if we want to name the compound, if we're given the formula, we use the name of the cation and we use the name of the anion that ends in "ide." Here you can see that in the examples we've got sodium Na and barium, and you can see I've pointed them out on the table. Those are definitely fixed charge cations. We simply say the name of those cations, and then we say the name of the anion with "ide." We don't use any Greek prefixes, so this first one is going to be sodium fluoride, barium oxide. The next one will be sodium oxide, and the last one, barium fluoride. Very straightforward. On the other hand, if we want to write the formula, given the name, we have to write, or at least think, the 2 symbols for the ions, and then we need to balance the charges. For example, silver sulfide, and again, I've located on this periodic table at the top the 3 cations that we're dealing with, silver, zinc, and cadmium, and you can see that they are all fixed charge cations. Silver has a charge of 1 plus, The sulfide ion, if you look on this periodic table at the top, sulfide ion is right here. It's going to gain 1 electron, 2 electrons, so that it will end up having 18. So the charge on the sulfide ion is 2 minus. And now, how many of each of these do we need to give us a neutral formula? We need 2 silvers and 1 sulfide. Zinc phosphide, zinc is right there. So what charge does it get every time it's bonded to something else? 2 plus. The phosphide ion, I'm going to use my laser pointer. The phosphide ion is right here on the periodic table, which means it's going to gain 1 electron, gain 2 electrons, gain 3 electrons, which means it's going to have a charge of 3 minus. How many zinc ions and how many phosphide ions does it take to give us a neutral compound? 3 and 2 respectively. Finally, calcium. Calcium is an alkaline earth metal, so it always gets a charge of 2 plus. And the iodide ion, let's see if I can find iodine. How about right there? Iodine is right here. It's going to want to gain 1 electron. So it will have a symbol of I minus. How many of each one do I need to give us a neutral compound? 1 calcium and 2 iodines.